In this video, I'm going to go through two recursive trace examples. I'm going to change one line of code and show you the difference and why it's important to keep track of the specific location of the instruction in the recursive call when you do this. I'm also going to show you how to write up a solution in a way that I would expect you to do on an exam in order to demonstrate that you understand how the data is structured during recursion. So we have two functions, and in the first function we have func1 of 5. So the simplest way to do this is you're going to have the stack and you're going to have registers. So I'm going to zoom in a little bit so you can see what's going on here. And you're going to have main, and then you'll just say func5, and that's what we're going to return. Next thing is we have func1 of 5 with the call. And we have a register of 5. And then what's going to happen here, if we look at this, the first thing we do is you multiply it by 2, and then we return and create a register, return val times func2, val minus 2, in the event that val does not equal 0. And we just return this. So then this becomes 5 times 2, and then we're going to do return val, in fact I'll zoom out a little bit, is equal to 10 times func2 of 10 minus 2. So now we say func2 of 8. So we pass 8, and now what's going to happen? Well, in func2, we first check to see if val is less than or equal to 2. It's not the case. Then we divide by 2. So in this case, 8 is going to become 8 divided by 2. Therefore, we are now going to have our recursive case, val of func1 of val minus 1 is going to be return val. So this case, it's 4 and 4 minus 1. So now we can bring this up here. We got func1, and it's going to be 3. And since we have not reached our base case yet, this case is going to be val is 0. We can then say, well, it's same process because it's recursive. So we got 3 times 2, therefore 6, and func2 is 6 minus 2. This becomes func2 of 4. And let's check our base case just to remind ourselves it's val is less than or equal to 2. So now we don't do that. So we're just doing the same thing. So instead of 8, the process is going to be 4. 4. This becomes 2 because it's 4 divided by 2, and it's 2 minus 1. So now this is func1. Let's check our base case. We know from going through this that the base case of func1 is going to be val is 0. So now that we know this, we got to multiply our value by 2. And so this becomes 1 times 2. And therefore, return val is going to be equal to 2 times func2. There we go. 2 times func2 of 2 minus 2. And now func2 is 0. And now let's investigate what happens here. So in this case, what's going to happen is it's less than 2, so we're going to print 2 and return 2. So print 2, return 2. We can put what we're going to print out at the bottom. So we're going to return 2 here. So this is going to be 2 times 2 equal to 4. So we're going to print 4 and return 4. So this becomes 2 times 4, which is 8. So we're going to now print 8. This becomes 6 times 8, which is equal to 48. And this is going to be 4 times 48, which is going to be equal to 192. And this is going to be 10 times 192, which is going to be equal to 1,920. So this would print out 2, 4, 8, 48, 192, and 1920. So let's run this code, bring up the solution, and we see that's 2, 4, 8, 48, 192, and 1920, just as we anticipated. So now let's change this around. We're going to move this line of code here. And let's see how this actually impacts everything. So now we're going to go through the same process. We have func15. This works just fine, but now what we're going to do is we have to completely change how we're going to approach this. So this is still going to be func2 of 8. And for the record, this is trace2 now on the GitHub page. So what's going to happen here? Well, we have to check to see what's going on because it divides by 2 first, then it will check. And that's going to be important when we get to our base case. So in this case, right for now, we have 8. We're just going to divide by 2. It's 8 divided by 2, which is 4. And now we're going to do the same thing with our recursive call because it's not less than 2. And now this is going to be 4, still 3. So things are still working out fine. We'll go through this same process. This would be 3. 3 times 2 is going to be 6. So this is going to be 6. Return val func2 is 6, and this becomes func4. 4 divided by 2. Now here's the key thing. 4 divided by 2. We divide by 2, and it's less than or equal to 2. So this is the important difference here. So what's going to happen? Well, 4 divided by 2, we're going to say 2 and return 2. So let's go through this process. Instead of doing this, we're going to say print 2 and return 2. So 2 would go down here at the bottom. And now this is going to be 6 times 2, which is equal to 12. And that's the value that's going to print out. So 4 times 12 is going to be 48. And then 10 times 48 is going to be equal to 480. And that's what the result would be. Now let's run this and see what happens. And we see that that's exactly what occurs. So why is this important? The reason why students sometimes struggle with recursion is because when they're working through it, they have to keep track of where the instruction is. When you're doing this, I strongly recommend writing it out just like I have, so that way you can see precisely how recursive functions go through and are implemented in the device and precisely how they are structured in the memory.